Hello, this is Mrs. Taylor, and I'm going to introduce you to differentials. So we have learned how to approximate a value using linearization, which is basically using the tangent line equation to approximate a value. And so now we're going to learn how to approximate using the derivative. So one method uses the tangent line equation, which is the equation of a straight line, which is why it's called linear. And then the other actually uses the derivative, but both are forms of approximation. And depending on what equation you're working with, one method may be better than the other. So the word differentials is referring to dy and dx. In general, those are called differentials. And the idea behind all of this is that if I am looking for the particular amount something has changed, and I have two factors in the scenario, so I have some change that's happening independently, that would be your x, and then something changing because of that independent factor, that would be your y, then I can estimate one based on the other. In other words, if I control x, I know how much it changes, so I can use that fact to find the change in y. And so remember, dx, dy is the same thing as delta x and delta y. It all means the same thing. And delta means change. So the idea is that delta x is the same thing as dx. And so let's say we have some point on our curve here and some point on our curve here. And so delta x would be the same as having your first x value and your second x value subtracted. So let's say this is x1, this is x2, and so delta x would be x2 minus x1. So that would be the horizontal change, or the amount your x has changed. And then delta y would be y2 minus y1, which is your vertical change. You know, you're changing your y values. And so with your corresponding x's and your y's, so this would be y1, this would be y2. And so if I put those two things on top of each other, am I changing y, am I changing x, that's the same thing as slope, which from Algebra 1 you should know is just y2 minus y1 over x2 minus x1. So all this is territory you're familiar with, but here's where it turns into something new. So the idea is that delta y over delta x is the same thing as dy over dx. We just replace the delta with the d, but the meaning's the same. And we know that this is the derivative, so this is the same thing as f prime of x. And if we control the change in x, so this is some factor in some scenario that I can control the amount of, but I don't know how much that affects y, then I can treat dy and dx like variables, and by multiplying both sides by dx, I can then create a formula or an equation for dy. And this is really sloppy. So in the end, we know that dy is equal to the derivative f prime of x times the, having trouble with the mouse operation today, dx. I realized up here that I should have written dx. Correct that right quick. Okay, so this seems like something that's just a trick, and it kind of is, but it's based in things that we know to be true. So what this means is that if I know how much x changed, and I can represent my scenario with an equation, then I can take the derivative, multiply it by the change in x, and then know the change in y. And so this is another way to approximate. And so this would be approximation with differentials using dy and dx. So this is what your problems will look like. Find the differential dy and evaluate dy for the given values of x and dx. So they give us this equation, y equals x to the fifth plus 37x, and they tell us x equals 1 and dx equals 0.01. And so really what this is saying is if x changes by 0.01, so if my horizontal distance changes by 0.01, how much will y change? Approximately. And so the first thing I need is my derivative. And so take the derivative of y. And normally we write y prime, but since we're using differentials here, let's write it as dy over dx. And so when I take the derivative of y, I get 5x to the fourth plus 37. Very sloppily. And it says find the differential dy. So remember previously the way we got dy by itself is we multiplied both sides by dx. So to find dy, I do the same thing here. And remember, this is a polynomial. So if I'm going to multiply, I need to use parentheses to show that the entire polynomial is being multiplied by dx, not just the 37. And then finding dy is as simple as that. It's basically finding the derivative and then putting dx at the end. So that's the first part. And then it says evaluate dy for the given values of x and dx. So what this means is we're going to use this equation to approximate how much y changes when x changes by 0.01. And so what I would do is I would substitute 1 in for x and 0.01 in for dx. Okay, so 1 to the fourth is 1, 5 times that would just be 5. And then 5 plus 37 is 42. And so 42 times 0.01 would be 0.04. And so if x changed by 0.01, I'm approximating that y would change by 0.01. And so that's how you use differentials to approximate values.